Hello, welcome to another CyMark webinar, one in a number of our series of webinars that we've been holding. My name is Paul Cook. I'm one of the technical specialists here. Today we're going to be looking at our new generation and range of RTUs and the new programming software. So we're very excited to be able to bring this to you. For many years now, we've had the E-series generation of RTUs focused on the DNP protocol and the standard series, which are more focused on the Modbus protocol. Both of these can be configured using our Workbench software, which gives you IEC 1132 programming language access. The standard SCADAPack also can be programmed using our ladder software, the Telepace Studio. So when designing a new generation of SCADAPacks, we've taken a lot of the features of both of these devices, and Schneider has combined them into one new range. So must stress that the standard and E-series still continue to be offered and still very much form an alternative for your RTU choice. You now have a third new generation to consider when looking at what your application is and which RTU is best going to meet your needs. When Schneider set about designing this new RTU, they had some key platform features in mind. The first of which was improving cybersecurity protection. So one of the challenges that we find is that you need to make sure that the logic execution of the RTU will continue unaffected if it's under attack through the Ethernet port. So having designed the hardware, we set about testing that using something called an Achilles test platform, making sure that the RTU is resilient to attack through the Ethernet port like that. The other way that other rogue devices or rogue actors, as they're called, may try and gain access to the RTU is through different port numbers and IP addresses. So the SCADAPack now includes some new support for something called IP whitelisting, which is another way of improving or limiting access rather to the RTU by improving its rejection of IP addresses and attack through different ports that might ordinarily have been left open. You also need to reduce the attack, what's called the attack surface area of an RTU, minimize opportunities for find to get in, and we can do that by turning off unused protocols and services on the RTU to make sure that you're minimizing your surface area. A second key platform feature that carried over from the E-series SCADAPack is Secure Authentication version 2. This offers another opportunity for companies to limit access to, or make sure that basically the RTU is challenging any requests or commands that are coming in and comparing those commands with a known security key and rejecting commands that are coming in from an unauthorized source. So we can do device and user authentication using this protocol. So we can make sure that if someone's trying to log on to an RTU or send a command to it, then people are challenged for credentials before commands are worked on. Recently this year, we added a new version of firmware in all of the SCADAPacks as well. Schneider's added in initially out of the box, the software needs to be, the RTU needs to be configured so that it will challenge the user for a password or not before you can get into the RTU. So that's separate from secure authentication. SAV2 provides a much more comprehensive way of controlling access to RTUs by users and devices. So what we've done with the X70 is combine two main platform features in the Modbus and DNP areas together into the same single RTU. Some more features that we've got in the X70 series. It is an RTU. It does only require a few volts of DC power to work and a few watts of power to operate. So still functioning in that off-the-grid type of application. It's still suitable for use in hazardous locations and ATEX applications. Also, there's a version which is a standard version, slightly less expensive, which is not suitable for use in hazardous locations to save a few dollars. Still supplying it conformally coated with zinc plating and on the steel packaging there, and then still with a good operating temperature range of -40 centigrade or Fahrenheit to +70 centigrade or some 140 degrees Fahrenheit there. This is our fastest CPU that we've had inside of an RTU to date, and we also have more memory installed on board there to give you more access to data storage. And And also with the faster CPU and some compiling of code that's happening now, you've got fast code execution as well. Big change here for users is now we're focusing on using object-based tag names in effect, programming with the SCADAPack, and then the user operates, or rather decides to allocate DNP or Modbus register addresses as needed. So you're not using these addresses continuously, you're just allocating them as you need to. It says here about 15,000 objects can be created inside the SCADAPack, of which about 6,000 can actually be used by the logic programming software. Modbus Scanner is also included, so instead of in the past having used Modbus commands and code to read and write values over Modbus, we now have a nice scanner included, so that's just a configuration there, so we'll save you some programming effort, and also should make data acquisition much simpler. Also included for a license fee is the ability to use RealFlow, the flow computer, the measurement there on the RTU. We're not supporting C programs on this RTU, so we have embedded, Schneider has embedded the RealFlow flow computer into the firmware of the RTU. And then we're supporting up to 10 flow runs, so we're not differentiating between water or gas or liquid, just a flow run. It's in 3 groupings up to 10 for licensing. So you just purchase a license, put that on the RTU, and you will find the RealFlow can be enabled. The logic editor has come from the Modicon PLC programming world. It's the Unity Pro software components that are being used to allow code creation on the SCADAPack, which is giving us the IEC languages, the ability to create your own function blocks, and the ability to work with the object-based environment. And fortunately, we're still retaining the online programming support. And we've also added a lot of support for Excel and XML, import and export of code and RTU configuration to improve the ability to do bulk configuration. So let's look more closely at the current range that we have available, and then we'll look at a range that we'll be making available later in the year. The 570 or 57X series, kind of comparable to the 350, 357 range of RTU for pricing and IO counts. We also have some adapters that allow people to migrate the SCADAPack 32s and ordinary SCADAPack with the P1 hardware to the 570, 574 RTU as well. Let's look into some more detail at those SCADAPacks. So we have 3 available currently. The 570 is basically the controller board with communications ports on board, so serial ports as you see here, 3 Ethernet ports, one of which has an IP address built in. The USB port is used to get online and do online configuration, or you can use the Ethernet ports for that as well. We've got 1 host port for adding in a USB memory stick and offloading data from the large amount of onboard RAM that has been installed. I/O is limited on the controller board to just 2 digital inputs that do support up to 10 kHz counter inputs with turbine amplifier built in, and 1 digital output on the controller board there. The second RTU is the 574. So the 574 is that same controller board, but with an additional expansion module packaged into the same unit. So you've got the controller board on top, and underneath is the expansion module. So that's bringing you some extra I/O capabilities. So you're looking at an extra 16 digital in, 10 digital out, and 8 analog inputs on this chassis. And an option when you order the RTU is to include 2 analog outputs right on this board. We're still supporting expansion modules with these RTUs, so if you need additional I/O capacity, that can be enhanced with the expansion modules that we'll look at later on. And the third RTU in this range is the 575, same controller as the 4, but incorporating a different expansion module, the 6601. So this is adding 16 digital inputs, and 8 of those can be used as pulse counters. As you see here, the different speeds that are available. We've got 8 digital outputs on that particular board, 6 analog inputs, and the option as well for 2 analog outputs, again, purchased at the time of ordering. So those are the 3 that are currently available. Coming up towards the end of this year, we're adding to the range another 2 more controllers, the 47X series. These are down in the price point, so we're aiming, they are an alternative if you're looking at a 330 or a 334 range of RTU. The 470 and the 474 are shown here. You can see somewhat different in packaging to the 57X series. We've got the terminals on the top here are now vertical instead of horizontal, and we've got some different USB ports available to us here, slightly physically smaller too. So the 470 is the 6602 controller, still programmed with the same programming software that we programmed the 57X series with. Pretty much everything there is the same. The board adds 4 serial ports, as you see here, with one somewhere in the lid there. 2 Ethernet ports, which are independent or switched. So we don't have that switched capability with the 57X, but we do here with the 47. A USB port C, not the B that's on the 57X and the standard SCADAPacks. A USB host port for offloading information, and a little bit more I/O. So we have 4 digital inputs with the pulse counters up to 10 kilohertz. So more pulse counting capability there. 2 digital outputs and 4 analog inputs on the 470 controller board. Take that controller board, add in a 6607 expansion module, and underneath there, and you've got the 474. So that's the expansion module all packaged in there, ready to go. That's adding in 16 digital inputs here, and you can see the extra counter support that's on there. We've got 10 digital outputs, 8 analog inputs, and the option to add in 2 analog outputs on that board then as well. So if you find that I/O is insufficient, then you do have the option of going to our range of expansion modules. So the range of modules that are compatible with this new generation are somewhat reduced from the modules that we can utilize with the standard range of SCADAPack. So you can see on the left here what the options currently are. 5000 series is our current generation, and we're starting to add in now what we call the 6000 series, and the 6000 series range are being extended to with this addition of the 6607 coming along. Expansion number of modules you can add in, about 15. If you already have one in the SCADAPack, like with a 574 or a 474, then you've got the ability to add in about 15 other modules, with the limitations that you see here, with the bus cannot be longer than about 75 inches in length, and that you might need to incorporate additional power supplies depending upon your expansion module mix, and that's something we can help you with at the time of configuration. We've enhanced the HART support significantly with this 6602 HART module. We have 2 modules available that can be used. Only one can actually be utilized with an RTU at a time. On the left here, we've got 8 analog in and 4 analog out. On the right, we've got the 8 analog in. We're supporting HART pass-through now with this device and with this HART card, so you can use your asset management software to configure the RTU, the instrument through the HART protocol through the RTU with the asset management software there, passing information through and allowing for easier configuration there. For existing SCADAPack and SCADAPack 32 users that might want to migrate, we helped a water utility in California migrate a lot of their older SCADAPacks to the new generation by using these terminal kits. So the terminal kit, this connector here was attached to the old SCADAPack. It was pulled off the old SCADAPack, complete with the wiring, and then slid on top of the terminal adapter, and then the terminal adapter was attached to the RTU. So they were able to replace one RTU, the old one, with the new one, without having to disturb too much the wiring. Caveat here is that this is a little bit wider possibly than the standard SCADAPack. So it's one of the things you might need to look at, is a space that might be available in your existing enclosure before you consider this option. Moving on to look at the configuration software, we call it Remote Connect. Remote Connect is the name of the software that's used to configure the new X70 series RTUs. So you would not use this to configure standard SCADAPacks or E-series SCADAPacks. Just the remote connect is just focused on the X70 series. So all these two different tools we have available are still current, still available for use with the older RTUs, but would not be used to configure this new generation. Some nice new features with this new software. It's free to download and use. We'll be including some links at the end that will allow you to be able to do that. No licensing here, and a great thing is this is all Schneider software. So we've taken, they're not working with any third-party companies to add this in, so there's no third-party licensing required, plus everything is wholly under the control of Schneider and supported by Schneider. So we're not relying on waiting on somebody else to fix issues if there are problems cropping up with a particular RTU. Everything is included and supported by Schneider. Telephone support and technical support still continues to be free, and then it's provided out of Ontario. And if you're calling the technical support numbers that are available in the help system, then you're connecting with somebody in Ontario that just deals specifically with these RTUs. That's really, really nice. You get very quickly through to someone that just works with these devices and can provide focused application support. And the development of the software is also handled in Canada as well. So we have the hardware and software development all together there. Very, very, very useful. The software is using it's a current technology called field device technologies, where you have FDT containers, or a container, which is remote connect, and then the data type managers or device type managers might be are actually putting into the container and used to connect to the RTU and do the configuration. So here you can add in extra DTMs, such as the heart instrument DTM, into the remote connect container and utilize that through the with the heart pass through for the instrumentation as well. The security administrator is provided, and if it's licensed, then as we mentioned, you can get access to the secure authentication across the SCADA system then. Object-based focus, and we'll see that in a moment, what that actually means and how that pans out, but you're starting with objects and not using Modbus or DMP addresses to program in your controller unless you actually need to, in which case the way to get information out of the controller is through the Modbus or DMP addressing. With the remote connect and the use of the Modicon programming software, we're back to offering the structured text, instruction list, function block diagrams, sequential function chart, and ladder diagrams, as well as offering some additional multitasking options with the code and giving you some more flexibility about how code is executed within the controller in a cyclical or periodic fashion as well. Nicely thing, you can take the existing instruction libraries and create your own, customize those instructions, lock them down if necessary, put them in your own libraries and reuse those across your projects. So allowing you to perhaps protect some intellectual property or just reduce your re-engineering time with some good reuse there. Online and offline programming support, as mentioned before, and we've got good Excel and also XML import and export of code and configuration in the software, so you can do some bulk editing much more easily. We're using today the emulator, and the emulator is built in. It's included with the software itself, so there's no additional purchase to be able to take advantage of that. So I encourage you to download the software and sit down and start to learn more about this RTU. So what I'm going to do now is bring up an existing running remote connect project. So when you first start up the software and start a new project, you're going to be prompted to make some decisions about which SCADAPack you're working with, and you can change that. So here we're currently supporting the 3 that are available, and the 470 and 474 will be added to this list once released. Because of cybersecurity, as I mentioned, you can turn on and off the different roles of the RTUs. That's limiting its footprint, limiting its access for people to try and get in. If you don't want them to gain access through these different ports, just turn them off. Here is where you would tell RealFlow that your SCADAPack is going to be used as a flow computer as well as an RTU. And by checking that, the software is going to check to see which Modbus addresses you're allocating to objects and make sure you're not doing anything that's clashing with registers that are being used by the RealFlow. So that will save you some problems and heartache down the road. So when I picked a 575 with this configuration. So then you're going to be having access to the configuration tree on the left here. This at the top level where it says SCADAPack, here you can see as I move the mouse around, we're getting some highlights on all the different areas where I can click. And what it's going to do is take me to different parts of this tree here. So this is a nice little summary with these tabs available here, and also on with the point-and-click interface, you can drill into some of the configuration that's also available to you on the left here. The help now contains information on the software, the RTU, as well as the RTUs themselves, input IO modules and SCADAPack, so you're not having to scratch around for some external PDF files. Context sensitive help is built in, so I've got an LED flashing here. I can click with the mouse and it'll bring up straight to the help here. So we're looking at the LEDs when they're flashing. We'll be able to interpret what the RTU is trying to tell us here, as well as being able to jump into any status words that might be available. So if we go to status here or store, you can see that. Under the physical IO and local area here, we can see here I'm just working with a single SCADAPack. If I need to add some expansion modules, I would do that from here. So you would pick from the range, as I said, somewhat reduced range of expansion modules that are available. You'd pick the expansion module you want to work with, give it a name, and then what the software is going to do is add in all those IO points to the list of supported IO and automatically name them. So you can see on the right-hand side here with the standard SCADAPack, each of the available inputs has been automatically named for me. If I double click on that, then it's going to open up the object editor, allow me to change the name of that. The IO is typically grouped into its own grouping. You can change and manipulate that as freely as you want. And here you would see the typical object editor dialog. So these tabs here will give me access to the ability to add in or give this object now a Modbus address. So by giving this object a Modbus address, I would be able to then pull this status of this input from an external source, from a SCADA host, for instance. You can see that this object is associated with some physical IO. The other way to view the objects, if we go to just this tab here, it just lists out for us all of the objects that have been created, IO, and objects that are linked to IO, which we can tell obviously by the name here or by the source details. Also, objects are being created for us that are linked to internal status words. So for instance, this object was created, which is showing us the CPU temperature. If I open that up, you can see that the source type is not IO, its source type is system data. So now this is telling me that. So you have access to a lot of different informational areas where you can pull out all sorts of stuff, the clock, date, time, all sorts of information to do with Ethernet ports, serial port configurations. Lots of information is exposed here for you, which you can then choose to put into an object. If you want to use the information that is in this object in your ladder code, you will need to change the logic variable type from none to one of the what we call SCADAPack data types. So by changing it to one of these data types, you would make that information accessible to the logic engine, which we'll be opening up in just a moment. If we take a look at one of the analog inputs, you can see here that we've got a few more tabs available to us to compare to a digital. And you've also got the ability to do some scaling here, amongst other things, right on the analog input. So you don't need to generate some code to do that unless you really like writing code to do scaling. All the objects have a Modbus and a DMP tab, so they all can give me a Modbus or DMP address if necessary or if required. I mentioned how we can now do Modbus scanning. So one of the options I enabled when I configured this controller was the ability to be a Modbus master. So here you can see I can add in a new device. I'll just leave the name as default. I can choose how I'm going to be polling, serial or Ethernet. Being Ethernet, I'm going to give it an IP address. Some other configuration parameters that are typical to do with Modbus are available to us here, and obviously the poll rate is set here for the device. Having added in the device, I can now then decide which points I want to bring back from that remote device. I'll just leave it at the default register address here. I'll make it 5 quantity of 5 points. By leaving these as 0, it's going to take the pull rate of the device. So I could actually choose to have these points scanned at a different rate if I wanted to. We're bringing in values from a remote device. These are actually going to if we want to use that information, we're going to need to connect them to an object. And what I'm going to do is just have the software automatically create those object names for me. So I could obviously go back and change those at a later date. It would also, if I wanted to, assign Modbus addresses to those for me as well. I'm not going to do that. I'm just going to choose OK here. So you can see pulling back 5 registers from this controller, from this address, and each of these has been put into its own object there in the object table. In addition to that, the software has also created for me some sort of status counter words that I can monitor, things like good messages, bad messages. I can turn the scanning on and off with some of these other objects that have been created for me. So if I choose apply, you can see now these objects are additionally listed in this entire table here. When you're using Remote Connect, if you're going online with the controller, you're probably going to want to see what the status of the objects is, what the values are. So this is where these devices, or called object browsers, come in. The first one it created for me automatically is the SCADAPack one. By clicking here, I can choose to add a browser. I added in a number of Modbus points earlier, as you just saw with the scanner. So I can choose to bring in, and those Modbus points were automatically named Modbus Slave Device 1. So I can just bring in all the objects from that particular Modbus device and they would appear here. So, so I now have 2 object browsers here, and I would anticipate that a running application will probably have quite a number of these object browsers configured. The object browser has a number of uses, reading and writing information to and from the RTU, using this interface, doing forcing, this type of thing. So that would be sort of other tasks that you would accomplish using an object browser, and they are stored within the RTU as well. One nice thing they've added in, you might be relieved to hear, is that the Ethernet port now has a built-in IP address. You can change this, but at least out of the box there's an IP address. So no scratching around for that USB cable. You can just get your patch cable out and get communicating with your SCADAPack straight away. Down at the bottom of the tree, here's where you would launch the logic editor. So I say launch the logic editor. So the Remote Connect software here is used for configuration. The logic editor is a separate piece of software running separately, and so you have two screens open. You could obviously have the logic editor on one screen and the Remote Connect on the other. So this is now how you're going to manipulate those objects you've created and build up your code and make the RTU do some useful work. So if anyone that's used the Unity from Schneider will be looking at this, should be familiar. This is, as I say, the Unity software that we've repackaged to work with the SCADAPack itself. These 2 folders here are where you would create and add in any custom created function block types that you may have created. Any libraries that you want to bring in would populate any custom user-defined data types and user-defined function blocks in this area. Let's have a look down here. So we saw in Remote Connect our list of objects. How do they appear in the logic editor? Well, here they are. So all of the objects that were created in Remote Connect, this is how they appear as derived variables inside the logic editor. You can see here with an analog that we have available to us and quite a number of different values to do with that particular analog word that's coming in from the I/O. Analogs and digitals all have this structure associated with them. There with the RTU temperature. No, the RTU temperature was not available because in the logic editor I had not set the data type to one of these logic types. So if by not being assigned a logic type, it does not appear in this list. If we went back and assigned that, it would appear in the list here, and we could use that in the code. So that's kind of how you make sure that objects are linked to logic or not, as the case may be. So you build up your variables, and the next thing you probably want to do is going to start to utilize those objects and do some programming. So this is where the program folder comes in. We have the ability to create under the tasks area here. So the master task has been created for us. We can also create a number of other tasks, such as the fast task and the auxiliary tasks. These are just different areas, different ways of grouping code and having them executed in different fashions, either cyclically or periodically. So it's good ways to manage code and code execution in the controller. Under the section here is where you would start to add your new ladder diagram, structure and text, function block diagram, sections of logic. If we start with the ladder diagram here, then, oops, should actually give it a name. Oops, that. So the first section of ladder code has been added here. We could go on and add other sections of other ladder code diagrams. So we're not limited to one type. You can keep adding different ladder code function block diagrams into this master task section, and they would just appear further in the tree. Do what you do also have access to the ability to add in subroutine sections as well, so you can have code that's only executed by jumping to that from the main program. If we open up the ladder diagram editor in this case, then what we've got available to us now is a sheet. So this does not behave like the Telepay Studio where you have a network. This is currently set to 11 columns and about 100 lines of code. You can actually extend this out to 64 columns and 2,000 lines of code as necessary, and that's just in one ladder file. If you were for some reason to exceed that, you could just add in another ladder diagram and sectionalize your code as necessary. So in the ladder diagram here, we're just going to put in some context, a little bit of motor starter logic, very simple. Just branch that together, get the volatile latch ready. So now to maybe add some inputs to that code, we can just drag these over. You can see here that these are just as we name them, so you would normally rename these, of course, to something that's more useful for you. You also have the ability with this alias column to give these objects like a dot value an actual useful name as well through aliasing, and I imagine that that is mostly what will happen. People will use re-alias these input names into something more suitable for their application. Oop, you just need a search on digital outputs. Search for that, and we'll go and pick the first output there and drop those down. So I'm running the emulator, as I say, so I should now be able to just we'll just do a start simulation there. And that will start executing the code for me. So this is how the ladder code is represented. You can see logic flow happening there. If I want to change the state of this digital input, then I can do that through here. I can also create something called an animation table. You'll see here. So an animation table then is just a listing of different objects pulled together and given a name. This was a temporary table because I just did the command to create a temporary table, but you can certainly create these tables and save them into this tree, and obviously they're then saved for future use. I'll just minimize this and group these a little better. So if I want to turn off this value, I can hit modification and then set this digital input to 0. And then we can just shut off the code by hitting our stop button, and the logic will stop. Also available to you are these things called operator screens. I've created one here. An operator screen is a nice way of maybe providing some visual representation of what's happening inside the controller. Could be used for diagnostic purposes, for commissioning purposes, whatever purpose you want to put it to, of course, because here you can actually set up objects like buttons and objects that represent the status of things. So I could actually set up a button here, which is going to do the same as me operating the animation table, which is set values, reset values, and I can see the status of all sorts of information of the objects that are in the controller there. So they're saved with the project in the controller, and could be a very useful way combined with the animation tables of providing some maintenance and troubleshooting assistance when you're trying to figure out what's happening with the code. Let's pop back to the PowerPoint. So I've made available a number of useful links here that will be in the PowerPoint. The first one is Schneider has prepared quite a number of YouTube videos on the Schneider website. So this link will take you to that playlist all about the Remote Connect software, the objects, how to use them, creating code, how to work with the HART instrumentation, working with the MP3. So quite a few different videos here that allow you to get up to speed on the software and the RTU. There is a forum that's available, moderated forum by Schneider with users in there talking about the hardware, talking about the software. So the forum is available to you for anyone to join in and join into that discussion. This is where you would get your hands on the Remote Connect software. So I've included this link here. So when you click on that, it's going to go to the Schneider site and open up a PDF. That PDF contains more links to allow you to download the Remote Connect, as well as our current versions of all the software tools and the latest version of Real Flow. This version is the one that's necessary to work with the Flow computer inside the X70. Mark Phillips, my colleague here at CyberArk, has also got his channel going with other videos he's built on talking about our standard SCADAPack, working with Real Flow with the standard SCADAPack. We've got other videos linked to playlists from the Schneider site, talking about our data radios, talking about our wireless instrumentation, and talking about CyberArk's off-grid power system, the E4 fuel cell. So a lot of good content here for you to check out. And last but not least, I included a link to Schneiders Exchange community. This is a newish site that Schneider's putting together to allow for users and engineering companies, end users, to get together and share solutions that they have, find solutions to problems that they have, buy and sell products through this site as well. So we have access to the SCADA suite software, which is a software solution used here on the standard SCADAPack to provide well testing and plunger lift applications as well. So you will be able to find that on the Exchange. The Exchange solves a lot of users and engineering companies questions and problems through this Exchange site. So check it out. So with that, I'm going to wish you a good day, and I hope you've found this information useful, and I encourage you to get a hold of the Remote Connect software and start to find out more about our new RTU series. Thank you very much for listening.